Okay, so in section 8.6, we use the following equation to calculate amount concentration. C equals N over V, where C is amount concentration expressed as mole per liter, and the amount, or N, is expressed in mole, and the volume V is expressed in liter. A more general equation for concentration C of a solution is quantity of solute over quantity of solution, where the quantity of solute and solution can be given in volume, mass, or both. And we see consumer products mainly expressed as a percent concentration. And percent concentrations can involve volumes of solutes in solution, masses of solutes and solutions, or both. So you might have seen something like this around your house. I just pulled out my bottle of hydrogen peroxide. Okay, so you could see that it is expressed as a solution, a 3% solution. So you might see other solutions in your house like that. I'm sure a lot of us have seen bottles of alcohol, isopropyl alcohol right now, that they should be around 70% to be most effective for keeping our hands clean from viruses and so on. So we are going to learn about how to find those percent concentrations today. So the first one we're going to look at is the percent volume, which we would calculate as follows. The equation for that is CV over V is equal to the V of solute, or the volume of solute, or the volume of solution. Now note, the units have to be the same to be able to find the percent times 100%. Okay, so simply put, this is a percent, and we're multiplying the volume of solute over the volume of solution times 100. So again, this is a ratio, another ratio. We can also look at it like this. The volume of solute over the volume of solution is equal to 100% on the bottom, and the concentration volume over volume. That's just another way to look at this, right? So we use this when both the solute and solution are liquids. The second type could be a weight, percent weight by volume, or percent W over V. We also see that like this, and it means the same thing, mass over volume. In this case, we would typically see the volume will be in milliliters. Of course, for our household substances, it's going to be milliliters because we have small amounts of substances around. For example, this bottle of hydrogen peroxide, is equal to 473 milliliters. So we're not going to use liters so much in our homes or in our household products. So the formula for this is the same. It's just what we were finding is different. So we've got the mass of the solute over the volume of solution. Again, times 100%. So the base formula is the same. Solute over solution times 100. We're just what we are using it for. In this case, the mass of the solute over the volume of solution is different. Okay, and the last type is a percent weight by weight, percent W over W. We can also see that as percent mass by mass. So in this case, we are dealing with masses only. Is equal to the mass of the solute over the mass of solution times 100%. Now remember, in this case, because we're dealing with masses, we have to, the mass of the solution is equal to the mass of the solute plus the solvent, because they will have differing density. I just meant to put solute plus solvent. Let's just fix that. Plus the mass of the solvent. And this is due to differing density. Otherwise, we are taking everything as the solution is the solution. We don't add up the solute plus the solvent to get the solution. Okay, and this is due to differing density. Now, when we are solving problems with percent calculations, the units have to be identical. So this is crucial. The units have to be, except for in the case of concentration of weight by volume, because of course you're dealing with masses and volumes in that case, but otherwise they have to be identical. And some conversions that are pretty handy are, well, we'll most often see these three, but a ton is equal to 1,000 kilograms, a kilogram is equal to 1,000 grams, kilogram is equal to also 1,000,000 milligrams, and a liter is equal to 1,000 milliliters. So those are some useful conversions when we are doing these questions. All right, so let's get through and do a question or two. So the first example says, dissolving boric acid in water produces a mild antiseptic that is useful in eye washes. What mass of boric acid is present in 125 grams of a 2% weight by weight solution? So again, crucial to write down what you're given and what you need to find to make sure that you're finding the correct thing. So I'm going to use mass of the solute instead of W. It's the same thing though, remember? That's what we're trying to find. Okay, what mass of boric acid is present in 125 grams? So the mass of our solution then is 125 grams. Sometimes hard to think of a mass being, a solution being a mass, but we can have it as a mass. So the percent weight by weight is equal to 2.5%. Okay, so the formula we use is percent weight by weight is equal to the mass of the solute over the mass of the solution times 100%. And so we're trying to find the mass of the solute. So I find in these questions it's easier just to leave, not to rearrange them. You can rearrange it if you like, but it's not really so necessary here when you try to look at what you're trying to find. So we put 2.5% is equal to mass of solute, over 125 grams times 100. So essentially we're trying to figure out what's 2.5% of 125, right? That's essentially what we're trying to find out. So we can put in our calculator, 125 times 2.5 equals, and then we divide by 100. Divide by 100, oh, I don't know if you can see that. Let's do that again. So 125 times 2.5, so I cross multiplied there, equals, and then divide by 100, and I get 3.125. So how many digits will I keep? Well, in essence, I have 3 there, so that's what I'll use. So 3.1, this is ending nothing after it, so we'll go with our rounding rule, so leave it as 3.12 grams. So the mass of the solute is equal to, so therefore, the mass of boric acid in 125 grams of 2.5% solution is 3.12 grams. Okay, put that out of the way, slide that over a bit. Okay, question 2. Gasoline contains as much as 10% volume by volume ethanol. What is the maximum volume of ethanol in a 40-liter fill-up of gasoline? So we're trying to find how much ethanol there is in 40 liters. That's 10% of it, essentially. What's 10% of 40 is what we're trying to find. So our concentration, volume by volume, is equal to 10% of it. Our volume of solution is equal to 40 liters, and our volume of solute is what we don't know. So concentration, volume by volume, is equal to volume of solute over volume of solution times 100%. So we have 10% is equal to volume of solute. I'm not going to rearrange. Again, just so we can make sense of what we're seeing here, times 100. Right, so we're trying to find out what this number is up here. So we use the same method as we did last time. 10 times 40 divided by 100. 10 times 40 divided by 100. And it's 4. So the volume of our solute is equal to 4 liters. Therefore, the maximum volume of ethanol in a 10%. Actually, I should have put in 40 liters. In 40 liters of 10%, volume by volume solution, of a 10% is 4 liters. Okay? Okay, next question. A 2.5 liter jug of household chlorine bleach contains 125 grams of sodium hypochlorite. Determine the percentage weight by volume of the bleach. So we're given 2.5 liters. We have 125 grams, so we can tell by that we've got mass and a volume. So we were asked what is our concentration of mass and volume. Weight by volume, mass by volume. So our volume of our solution is 2.5 liters or 2,500 milliliters, and our mass of our solute is 125 grams. So concentration, mass of volume is equal to the mass of our solute over the volume of our solution. And remember, in this case, it has to be in milliliters. This is why we made the change. Times 100%. Concentration of mass of volume is equal to 125 grams divided by 2,500 milliliters times 100. So let's do that. 125 divided by 2,500 equals oops, that's not right. Technically cancel those out, but anyway, 125 divided by 2,500 times 100 equals 5%. So C equals M over V is equal to 5%. Okay, so therefore the concentration mass over volume of 125 grams of NaClO and 2.5 liters is 5%. Okay, next question. We have what volume of 30% weight by volume hydrogen peroxide solution is required to prepare 425 mils of a 6% weight by volume solution. So what do we have here? This is a little bit different because we're given 2%. Hopefully this looks familiar from our lesson in dilutions. So this is a slightly different question. So we are given essentially the concentration of our dilute solution is 6%. and our volume of our dilute is 425 mils. How do we know? Because it says 425 mils of 6%. So that goes together. So our concentration of dilute is 6%. Our volume of dilute is equal to 425 milliliters. And this is our concentrated concentration. C is equal to 30%. And we want our volume of our concentrated solution, and that's what we don't know. Okay? So CCVC equals CDVD, and we're solving for VC. So we have to divide both sides by CC. So VC is equal to CDVD over CC, which is equal to 6% times 425 mils over 30%. And when you put that in your calculator, you get, so 6 times 425 divided by 30, 85 mils. So therefore, 85 mils of 30% of hydrogen peroxide is required to prepare 425 mils of 6% solution. Running out of room here. Okay. Okay, so that's essentially, those are your consumer concentrations. There's a second part to the lesson, which you'll get tomorrow, where you will learn about extremely low concentrations. So you should read through 8.8 and prepare to do some homework tomorrow from both the sections. Okay, thank you for your attention. Bye for now.